but we are the health ministry. Also, Pastor Erickson, who is with us as well. I would like to thank and to thank for their support and help along with the health ministries team. Now, before we start, I just have a reading because we're going to be having a presentation this afternoon on health by Dr. David, but I just want to do a little reading so that we get a flavor of health and also what the Bible and Spirit of Prophecy says. It's just a short reading that I'll read. And this is on the Health and Personal Ministries department. And it states, we have, no, sorry. Right, this is from Ministry of Healing, which I believe some of you may know the book or have heard of it or have it. And in Ministry of Healing, chapter 7, it states, in the ministry of healing, the physician is to be co-worker with Christ. The Savior ministered to both the soul and the body. The gospel which he taught was a message of spiritual life and of physical restoration. Deliverance from sin and the healing of disease were linked together. The same ministry is committed to the Christian physician. He is to unite with Christ in relieving both the physical and the spiritual needs of his fellow men. He is to be to the sick a messenger of mercy, bringing to them a remedy for the diseased body and for the sin-sick soul. Christ is the true head of the medical profession, the chief physician. He's at the side of every God-fearing practitioner who wars to relieve human suffering, while the physician uses nature's remedies for physical disease. He should point his patients to him who can relieve the maladies of both the soul and the body. Okay. And I would like to now introduce Dr. David for this afternoon's program. He's a former member of the Wellington Central Church for some years now, from 2003, I believe you were here, and left in 2010, in which he's now residing at Coffs Harbour in Australia. So all the way from Australia, David, we would very much like to thank you for presenting to us. And I know that we'll be blessed from your message, you know, and I pray that God will continue to use you mentally, physically, and spiritually.
Well, happy Sabbath, everyone. Sort of a muted. I know that we just had lunch, so that's okay. While I'm waiting for the slides to go up, yes, I used to be here, and we left in the end of 2010. We were in Sydney for until about 2 years ago. Then we moved up to Coffs Harbour. And we're glad to be here. I'm just here for a couple of months, helping out at the hospital. My daughter's here. She's her name's Zaramali, and my wife's just arrived. Welcome. But we've got about, I think, 3 more weeks, and then we're heading back to Coffs Harbour. All right. Look, just before I move, just some small print. These slides you can get from the web. That's the first thing. But there are some slides that belong to Dr. Chester Kuma. I don't know, some of you who've been here long. He used to be the associate Yeah. Or he used to be the health director of the South Pacific Division. All right. So I've used some of his slides. So before we start, do we have an online audience, or is it just us? It's just us? All right. So it's good to see you all. How many of you have heard of the term epigenetics? Yeah, some people have. Excellent. This will be a down-to-earth presentation. I will try and make it as simple as possible, and it's the principles that count. All right, it's the principles that count. I've split this into 2 talks, otherwise it'd be too long. And I usually have I like to tie these things with biblical reference, biblical principles that we all know, all right? So I think all of us knows what's the good diet to have. You know, we all know the good and the bad, don't we? We know smoking's bad for you. We know alcohol is bad for you. We know drugs are bad for you. I'm not going to repeat those things. We know those things, yeah? A lot of times it's the application of this in our own lives that matter. But what I want to do here today is actually go a little bit deeper under the surface and looking at the science behind some of these things and how it really reaffirms our health message. So I think I'm here this week, and maybe a couple of weeks from now, there'll be the second part of this, yeah? So without further ado, let's get into it, all right? Let's see if this works. Well-known text, yeah? We are created by God, and I like this. It says, let us make mankind in our image after our likeness. And, I was interested in the service today, remember, about God. And I think I could summarize what, in my own words, what the message for today was. We took this in the other way around. We say, let us make God in our what? Likeness. As opposed to God saying, I made you in my image. And there are some fundamental building blocks in our system that can only come from a maker or creator, all right? But I think that's a very important thing. And now these are slides from Dr. Chester Kumar. And it looks at, the world looks at things in terms of communicable diseases, i.e. infections and things like that, versus non-communicable diseases, i.e. lifestyle diseases, all right? And if you look at it, in every health system in the world, these conditions threaten the healthcare system. Every healthcare system is broken, all right? Dealing with this. In some parts of the world, it's the communicable diseases. We experienced a bit of the communicable disease, didn't we? All right? But in some places, it's an ongoing issue, not just something that happens for 2 years and goes away, all right? But in some parts of the world, and unfortunately, it is the poorest part of the world, that it is the non-communicable diseases that are causing disasters. And these are high blood pressure, diabetes, cancers, things like that, all right? And so these next few slides are statistics from Chester Kumar when he was the director or health director at the South Pacific Division, looking at things of disease pattern and trends in the South Pacific, all right? And it looks at in terms of balances, yeah? Is it skewed in terms of communicable diseases or is skewing towards non-communicable disease? And so we have an example of a country where it's right in the middle, just about, all right? Papua New Guinea. There's lots of communicable diseases as well as non-communicable disease. So the disease burden is almost the same, all right? And then we look at the Solomon Islands. It's starting to skew towards what? Non-communicable diseases, starting to move that direction, all right? And then we look at Fiji. It's moving more and more towards non-communicable disease in terms of disease burden, all right? And then you go to Samoa. It's more to, it's shifting, all right? And a country like Nauru, it's almost all non-communicable disease is really overwhelming the health system there, all right? So this is what you can, if you put a lot of countries, there's a lot of flags down there, but this is the trends in the South Pacific, that as you move towards PNG up to Nauru, all the countries of the Pacific are in the middle of there. And, you know, there's a big problem because how to deal with some of these things like cancer, diabetes, high blood pressure, if you're using the treatment models that we have in developed countries, you find that you just don't have resources for it. You don't have resources for it. So for example, in some cases of diabetes, you might need to give insulin replacement. Yeah. And the insulin needs to be kept in the fridge. Well, if you're out in the rural villages and you have problems like that, you can't store something like that. Yeah. So let alone the cost of those drugs or medications or things like that, the whole cost of delivering that kind of care, it's impossible. It's impossible. So this situation in the Pacific and some of these countries, one could almost say that it is of epidemic proportions. And we talked about the COVID-19 epidemic. Well, transfer that and look at it from the perspective of non-communicable diseases in these countries. It's really devastating. All right. So, what do we do? I mean, where do we look for solutions to this? And I think you know the solutions. I don't need to tell you today, but I will want to go in to some of the basis of in the scientific world to, what's the right word? To say to us today that our message of health has strong scientific foundations. Yeah, but you don't need that to have a healthy lifestyle, but I think sometimes it's good to have that, to know that as science progresses, more and more, it is simply affirming on a scientific basis what we know already. Is that clear? So bear with me, because we're going to go down now. I've got my here to help me. But so I want to go down now. You know, we to understand the universe, we look up where? We look to the skies, yeah? Well, to understand the body, sometimes it's useful to look within ourselves, all right? So right there is a picture of what? Do you know what the picture of that is? Chromosomes. Chromosomes. You all know that. In fact, how many of you have been, somehow you managed to do your own chromosomal stuff? It's not hard to do. You just take cells from your chick, culture them. We used to do that first year at university for our own self. It doesn't come out that good. In fact, the pictures all over, you have to cut it out and combine them together. It's all over the place, all right? But how many pairs do you have there? 20? 23, good, good. So 23 pairs, and that means 46, yeah? And there are 23 pairs because one of them comes from who? Your father, and the other one comes from who? Your mother. All right. And the last one, the 23rd pair, is called a sex chromosome. Depending on which one you get, you turn out to be a boy or a girl, a man or a woman, a gentleman or a lady. Does that cover everyone? All right, good. just making sure. Just making sure. All right. So now we go in a little bit more deeper. All right. You stay with me. So what you have is a cell, and within the cell, there's this thing called the nucleus, and that's where all these things lie. And production of those, all those chromosomes are in the nucleus, all right? And if you take them out like we did the first time, and you unravel it, it looks like a double chain, all right? That knocks each other, all right? We're going to go a little bit more. So it looks like a chain, but every now and then you've got these round things in the middle that holds them together. Okay. So, the pointer. Oh yeah. Okay. So you've got these things here, round things. If you open them up, they're in between these things, and they hold them together. And we'll come to talk about what their role is there. But essentially, what happens is that you've got something like that. That's a chromosome, and it's got this rounded thing we talked about. And we label them. See this G, T, C. Basically, in response to each of these bases, there's G, T, C, A, and they complement the other side. If it's G here, the other side is C. If it's T here, the other side is A, and if it's C there, the other side is G. And that's the same pattern that goes all the way through it. All right? So that is on the basis who we are. It's in that. Now, I want to tell you a little bit more before we get it. So each of these, say, I've got this, so this is gene 1, gene 2. This contains all the information about ourselves. All the information about ourselves. It's in there. All right? So what happened is that when we're looking at diseases, then there was this thing called the Human Genome Project, all right? Because the idea was that if we can map out what our genes are, maybe we can find out about these diseases, all right? And find out, okay, even if you find out what it, maybe we can fix it, all right? So took 13 years. We found out that it will cost a lot of money, but it's done between different countries. And we found out that it's we have 25,000 to 30,000 genes. All right, that's these packages, these short packages, all right? And not only that, we found out in the end that, yes, you might have all these things about the genes, but it's really only useful for really simple genetic problems, all right? As an example, so that's just a summary from what I've just said so far. Those DNA contains all the data necessary for our life, right? And then each of our code is unique and doesn't change, right? Once you have it, that's it. It doesn't change, all right? And with each birth, obviously, there's a new reset, as it were, for the next generation, all right? Okay, now, so the study of genetics is really a study of heritable diseases or heritable changes in DNA. Very important distinction, and I'll come back to it. So it is what I've just described with the Human Genome Project and talking about genetics of what you pass to the next generation. We're really talking about heritable changes in DNA, all right? That DNA is the substance that contains the code, that is the code that gets, that is you or me, very individual, all right? Now, so when I say simple conditions, it's something like this, right? So you recognize this, this kind of phase, yeah? Yeah, we recognize that. And if you recognize that, you don't really need to do any studies actually, but if you do the chromosome, something different there. What's the difference? It's in red. You notice that there's what? There's an extra one. All right, so there's an extra one. So that this kind of picture, if you see someone like that, you just do that chromosomes, you'll find that they actually have an extra one. So just having an extra one causes some issues. All right, but that's not the most common issue. Remember what we're talking about? What's driving the problems in the world is these communicable diseases and these non-communicable diseases. That's the vast majority of issues we have. We don't really have issues with this thing. I mean, they're there, but they are a small minority of in terms of problems that we have. It's not so much this, it's what I've said in the beginning, yeah? The communicable diseases and the non-communicable diseases. So I just want to mention that, talking about DNA changes that goes from the parents to the children, causing something like this. But that's not the answer to the question that I said, why are we having all these things, yeah? All right, so let's I want you notice this now. Do we all recognize this, don't we? Yeah? What's that? Caterpillar? Yeah, and yeah, something beautiful can come from something like this, yeah? All right, right. Next one here. What's the, these are what? Bees, and I've labeled them for you. So there's a worker bee, there's a drone bee, and a queen bee. All right, now, what are those two? Twins, all right? And what kind of twins? Identical twins, they're the same, yeah? So what's the same in these three pictures here? What can you say? Let's start from this one. With this identical twin, is there a difference in genetic material in these two? There's no genetic material difference. They're exactly the same, all right? Because they are identical twins, all right? What about this one? Are there any genetic difference between these? Any change or no? Maybe, okay. What about this one? Any difference in genetic material between this one and this one? No. Who says no and who says yes? Come on, put your hand up. Yes? Yes, there's difference. Anyone say no? There's no difference. Oh, I'll just go by the vote, sorry. But that's the fundamental thing, is that there is no genetic difference. All right? No genetic difference. The DNA here is the same as here. You understand now what I'm saying? And so it's the same with this one here. There's no DNA change between the worker, drone, and the queen. They simply have different food. That's how they all are drones to begin with. They're all here. And depending on the food and what they feed them, one becomes a queen, the other is a drone. But the genetic material is what? It's the same. That's the point. That's the point we want to make, I want to raise here. So, how is that possible? All right, now, if you think about it, and I don't have it, I think, with these slides, but when you're born, right, when you're in the mother's womb, what do you look like first? You're a mass of cells. It's just nothing. Now, but you have all the DNA you need for you. And then what happens? Suddenly, eyes started appearing, arms started forming, your heart starts to form. So is that from new information? No, it's not from new information. What's happening there then is that we have this. You could think of it, I like to use the word switch. So it depends on what genes are switched on at a particular time, right? So at the right time, the switch turns on for the development of the heart, for the development of the limbs. And then as it becomes more refined, it switches some off while it switches some on, all right? So this is, we start to realize then that we might not have all the technology, or we might not be able to change someone's DNA. But what if we can control the switches? What if we can control the switch to our DNA? So we silence this particular gene so that it doesn't express that abnormal thing. Or we turn on this thing so that it doesn't express that. Well, that's what's happening here. You know, all that happens is that certain switches are turned on at certain times to allows this to become this. And then when the time comes, certain switches are turned on and certain switches turned off, and you have what? A beautiful butterfly. So that's really the concept I want to illustrate here today. So let's move on. So this is what's happened. You know those round things there? They happen to be part of the switches. All right. So if I come, the next one here, this is from Google, you'll find this image, but I think it's a good thing because it tells you where the switches are. So for example, if I do something to this, it will stop the DNA being expressed. Or if I do something to this, so there are different switches that we have along that same chromosome that will determine whether a gene is expressed or not. All right. So this is what we call epigenetics. All right. And so this is again the same thing to illustrate it. You've got this is the chromosome, and then if you open it up, this is what you find. This is the round stuff that we have, and here you go. Sometimes gene becomes active when it's clear of these things on the top here, and when those things are touched there, it inhibits the gene. And the same thing here. Okay, this thing goes there and it inhibits it. When it's not there, the gene is active. So these are the switches we have inherent in our whole chromosome that determines what is expressed and what is not. Understand that? Excellent, excellent. We've achieved what we say. So same as well, this is the same thing. No genetic difference. All the DNA sequences are straight, but it's been expressed differently. So this is what epigenetics is. It just means outside of the gene. All right? Outside of the gene is what epigenetics is. And really, we will find out, and I haven't demonstrated this, but this is a part of the next bit. It's a study of heritable changes in gene expression. In other words, heritable changes in the positions of the genes, switches, I should say, sorry. Yeah? The question is, if a gene is turned on, or if it's turned off, is that something that can be inherited or not? We know that DNA is inherited. There's no question about that. But could it be that some of these switches, or the positions they are, or the state they are, could they be inherited as well? That's an interesting proposition, isn't it? Okay, well, so that's really what epigenetics is. Now, so far, I mean, I will go, I think I've switched this. Unfortunately, I didn't have the time to really look at this slide order. So it might be something that's on here that I'll talk about just later. So genes are expressed depending on time and requirements. So we know that, yeah? The caterpillar, and the butterfly, all right? And and I'll demonstrate this. There are heritable gene expression alteration that what I'll show in the next few slides is that the position of where these switches are can be inherited, all right? Okay, so, and it leads to heritable susceptibilities. Again, I'll demonstrate it in the next slides. And that there is a generational persistence of these abnormalities or switch positions, all right? Okay, and it's not necessarily a reset. As you see in a DNA, when a new child is born, the DNA is new. It's parents, yeah? So it's like it's new. Well, the thing about this I'll demonstrate is that it doesn't necessarily reset in the next generation. All right. Okay, so now let's go a little bit more. Okay, maybe, yeah. So perhaps nature or nurture, as we say in terms of diseases, perhaps that can be better expressed as nature and nurture. All right? Okay. Now, this picture here. Question. How many generations are in this picture? Take us how many? 3? Which is the first one? The mother? Yeah, and where's the second one? The baby, and what's the third one? Huh? X? Yeah, he's seen this before. He's seen it before. So there are 3 generations in this picture. All right, the 3, and so you get something like that. So that's it. You see. So the mother, the baby, and the cells of the next generations are already in that baby. All right, in the ovaries of the baby, there's already the cells for the what? The next generation. All right. So how many people are this person feeding? Yeah, there's obviously I'm smoking. Yeah, I'm drinking. Yeah, that's me. But what they don't thinking is the second one is drinking. Yeah, and the third one is also drinking. The first one is smoking. The second one is smoking. And the third one is smoking. Generational. All right? So let's go down a little bit more and look at this experiment. So you don't worry about this, but the key thing is that they injected this mouse with nicotine. All right? All right. So this is an experiment using for asthma, actually. But there's lots of slides, but there's also some for cancers and some, but I'll get that for the next talk. So don't miss out. All right. but this is using asthma. So what happens is you give the nicotine here. This one's got nicotine plus another drug that will inhibit its effect. So you find that in the next generation, F1, these rats, they do not have any exposure to nicotine, but they have asthma. All right. And the same for this F2 generation, which they come from obviously the reproductive organs of this one. You see? So they have asthma on the top. These don't have any exposure to nicotine, but they inherit those epigenetic abnormalities for predisposing to asthma. Now, what I'm saying here is now well established. It's not something experimental. This was experimental, but you do population studies, and I'll talk a little bit more of that next time we meet. But that demonstrates now these are females, all right? So the question is, what about the males? Yeah. Well, the next one here is more about the males. Now, so this one, these are nicotine in these rats that are fed in their drinking water, all right? And you see that in the first experiment, but at the time that the study was published, they didn't study this F2, the next generation down, but this one they did. And clearly the same thing happens. Both male and female that have been exposed with someone that had exposure to nicotine were affected right to the third generation. And this was associated with learning difficulties, right? These rats had learning difficulties, so behavioral problems associated with the exposure to nicotine. All right, so what it implies is that even though these generations have nothing to do with that, have no exposure at all, they inherited those behavioral disturbances that are associated with it. So it moves, that's what I said previously, the inheritable, it becomes a generational thing. Now, this is profound, because I might say that my parents never smoked, my grandparents never smoked. But remember the explosion of smoking, in the 40s, 50s, 60s, 70s, how many 80s? It's only recently that the smoking incidence has gone down as people are more and more. So we might say, I'm not smoking, but this tells us what? The generational effect of our grandparents or these generations that are heavy smokers, even though none of us are, you will still see these effects. That's profound, isn't it? I mean, we talk about the baby boomers, but a lot of us are not far from that generation, aren't we? We're not far from the generation. And with this kind of studies, what it's saying is that it's not surprising then that we see, even when there's seemingly no exposure to some of these bad things in the environment, that the effects still seem to go through to the next generation, They think, just based on this, that if this generation, it was just this generation and none of these, it'll probably take 3 or 4 generations. Understand that concept? All right. We're finishing now. Once I get the scriptures, we're finishing, all right? Sorry. Yes, you can. We can probably open to ask questions. I thought we are going to sing or something, but yeah. Well, those are, in fact, the babies passively spoke. And everyone in the story, but it's a little bit different from what you're saying. You're saying that someone who's just next to you and smokes. Yeah. No, that's different. I'm talking really about these experiments. Those next generation are not exposed to anything. That's what the experiment is trying to tell us. Yeah. They're not exposed to anything. But it seems that those in this, the first one was asthma, the second one was behavioral problems, and I can probably next I'll put some cancer data and that stuff like that. But it seems that the risk based on those epigenetic problems seems to be inherited, and it goes through generations. Right. So what you're saying is passive smoking. You meaning I'm next to someone who smokes. Yeah. That's a little bit different. You are actually directly exposed to this. What these experiments are suggesting to us is that it doesn't matter whether you're not exposed. The changes that were done in the first generation that were smoking had gone through, and it seemed to suggest that those switches I've told you, if it happens to be in the on position, it's inherited as an on position, an on position, an on position. If it's an off position, it's inherited as such. So that's what it suggests. All right. So to me, it's really profound, because if you think about smoking, probably those of you in developed countries where the smoking habit's been there for long, it's only recently that the level has gone down, isn't it? But the effects of those will be generational, and so it wouldn't be surprising to still see some of the problems that the smokers themselves have further down. Now, remember, what this leads to is, it doesn't mean that you will have it. It just means that you are susceptible, there's increased susceptible to those same things. Clear? All right. So I always like to tie it off in the end with some biblical stuff. And this is 1 Corinthians. What does it say? All these things happen to them as examples, yeah? To warn us against doing the same things that were written down, so that we could learn them or read about them and learn from them in these what? Last days as the world nears its end. So this is Paul talking about where these examples he's talking about. Where is he referring the readers to? Yeah, to the Old Testament, isn't it? He's referring to the Old Testament. All those things are there. Go and read them. They are for examples. They are pertinent and relevant to these our last days. So I just want to do that a little bit in terms of this. And so this is Exodus 15. So right after Red Sea, right? Red Sea, Exodus 14. Exodus 15, this is what the Lord says. If you what? Pay attention to his commands and keep this. Moses saying to the people, if you pay attention to his commands and keep all his what? Decrees, I will not bring on you any of the diseases I brought on the Egyptians, for I am the Lord who heals you. Fair enough? Yeah. But he's tying health to something. What's he tying health to? Obedience to his commands. All right. So again, here, more specific. Again, this is after Exodus 23. So it's after Exodus 20 and the laws and everything were given. He's re-emphasizing this. And again, he says, worship the Lord your God, and his blessing will be on your food and water. I will take away sickness from among you, and none will miscarry or barren in your land. I will give you a full life span. Again, their health is tied to what? Worship. The health is tied to worship here. This is what, and he's saying it's a little bit more detail here than in the first verse, in the sense he's saying your food and water. So there is something in the food and water that the Lord prescribes to us that would lead to what? A full lifespan. All right. So, but there are some passages in the scriptures that is a little bit difficult to explain. Yeah. For me, one of these is this. What does it say? I mean, this is Moses stating, I want to see your glory. And this is his reply, right? And he ends it with this. I'll just read the last bit. It says, keeping steadfast love for thousands, forgiving iniquity and transgression and sin, but who will by no means clear the guilty? And this part here sort of gets me a little bit. Yeah. What does it say? Visiting the iniquity of the fathers on the children's children to the third and the what? Fourth generation. So what's he talking about? Well, we know this, yeah? This is Deuteronomy 24:16. Moses saying, parents are not to be what? Put to death for their children, nor the children put to death for their parents. Each will what? Die for their own what? Sin. So is that what he's talking about in the other verse? And this one here, this is more clear. The one who sins is the one who will what? Die. The child will not share the guilt of the what? Parent, nor will the parent share the guilt of the child. So you start to think, what is this thing that is going from one generation to another, to the third, and interestingly, he says to the fourth generation. All right? But clearly, it's not guilt of sin, is it? Because that's nothing to do with that verse. I mean, these verses tell you that that's not what he's talking about. So I want to end with this. Remember, I said those studies that were done, the first one, even if the next generations don't, it takes up to 4 generations for that effect to go away. Unless, of course, that generation keeps doing it. All right? If that generation keeps doing it, then those things will continue, and it'll be, it'll just devastate the health. But this is, I'll end with this because this is Ellen White here. And I just want to focus on this little bit here, which says, Christ bore the sins and what? Infirmities. What is sin? That's the guilt of us, yeah? That's our guilt, transgression of the law. That's what is infirmities? That's the physical side of us. That's the physical side of us. And it says what Christ what? He bore that. He bore the sins and the infirmities of the race as they existed when he came to the earth to help men. Imagine, and in fact, it went up here, it says, here Christ overcame in the sinners behalf for how many? Thousands of years. Now, all I've talked about is a generation. Yeah, that's all I mentioned in the studies. What the Lord 7 saying here is that 4,000 years of infirmities is what the Lord bore on our behalf. Next week, I'll extend on to this, or is it next week or the week after? And carry on again with epigenetics and then tying it with what Christ did for us at the cross. Thank you very much. Anyone can ask questions if you want to, but that's where I'll finish. Thank you very much.
Okay, thank you.